Have you ever had that strange feeling, that sense of déjà vu, or a moment so surreal it felt like a glitch in a video game? What if I told you that feeling might be more than just a trick of the mind? What if our entire existence, everything you see, feel, and know, is actually part of an incredibly advanced computer simulation? It sounds like science fiction, but some of the brightest minds on our planet are taking this idea very, very seriously. Today, we're diving deep down the rabbit hole to explore one of the most mind-bending questions ever asked. Are we living in a simulation? Let's start with the simulation theory itself. The core argument, popularized by philosopher Nick Bostrom, is surprisingly logical. It goes like this. If you assume that a civilization can become advanced enough to create incredibly realistic simulations of reality, and that they would have a reason to run them, maybe for scientific research, historical study, or even entertainment, then the number of simulated realities would eventually far outnumber the one single base reality. If that's the case, basic probability suggests it is overwhelmingly more likely that we are in one of those countless simulations, rather than the original, unsimulated universe. Think about how far our own video games have come in just a few decades. We've gone from simple pixels in Pong to hyper-realistic virtual worlds. Give us 1,000 years, or 1,000,000, and what could we create? We could simulate entire universes, complete with conscious beings who believe their world is real. And if we could do it, why wouldn't someone else, far more advanced, have already done it? Now, let's take this idea a step further. If it's possible to create a simulated universe, what's to stop the simulated beings inside that universe from eventually creating their own simulations? This leads to a dizzying concept of simulations within simulations, like a set of Russian nesting dolls. Our reality could be just one layer in an infinite stack of digital worlds. The beings who created our universe might themselves be nothing more than lines of code in someone else's simulation, and so on, and so on. We could be a simulation run by beings who are themselves a simulation. This makes figuring out if we're in the base reality almost impossible. Each layer would be completely unaware of the one above it, just as a character in a video game has no idea about the player holding the controller. The very laws of physics in our universe could simply be the rules programmed by our creators. This is where things get even weirder. Some physicists have proposed a fascinating and related idea. What if our universe is located inside a black hole? It sounds crazy, but the math is intriguing. A black hole is a point of infinite density, a singularity, where the known laws of physics break down. According to some theories, when a massive star collapses into a black hole in a parent universe, it could create a new, expanding baby universe on the other side. From our perspective, inside this baby universe, we would see a Big Bang and a cosmos that expands, just like we observe. We would never be able to see or interact with the parent universe from which we came. In this scenario, every black hole in our own universe could potentially be a gateway to another new universe. This creates a kind of cosmic family tree, where universes are constantly being born from one another. Whether you call it a simulation or a child universe inside a black hole, the implication is the same. Our reality might be a self-contained system that originated from something outside of it. The connection to quantum physics adds another compelling layer to this whole debate. At the tiniest subatomic scales, reality behaves in ways that are completely counterintuitive. Particles like electrons don't seem to have a definite position until they are observed. This is a core principle of quantum mechanics, known as the observer effect. Before you look, a particle exists in a cloud of probabilities, a superposition of all possible states at once. But the moment you measure it, its state collapses into a single, definite outcome. Why would reality work this way? Well, think about a modern video game. The game doesn't render the entire world all at once down to the last detail. That would take an impossible amount of computing power. Instead, it only renders what the player is currently looking at. The rest of the world exists only as data, as potential, until it enters the player's field of view. Could the observer effect in quantum mechanics be a sign of a cosmic processing saving measure? Is the universe only rendering reality when a conscious observer is there to look at it? This leads directly to the idea that our universe might be fundamentally digital. Physicists have discovered that there seems to be a smallest possible unit of space, time, and energy. It's called the Planck length. You can't have a distance smaller than the Planck length. This suggests that space-time isn't a smooth, continuous fabric. Instead, it might be made of discrete, tiny units, like pixels on a screen. If the universe is pixelated, it's a huge clue that it could be the product of a computational process. Just as a digital image is made of millions of individual pixels, our reality could be constructed from a finite number of fundamental units. The smooth, continuous world we perceive would just be an illusion, a high-resolution render of an underlying digital grid. This idea, known as digital physics, suggests that the universe is essentially a giant computer, and the laws of physics are its algorithm. If the universe is a computer, what is it computing? The answer might be information. Some theorists, like John Archibald Wheeler, have proposed the concept of it from bit. This idea suggests that every physical thing in our universe, every particle, every star, every galaxy, originates from information. The physical reality, comes from the bit, the fundamental unit of information. In this view, reality isn't made of matter and energy as we traditionally think. It's made of information. The physical world is just a manifestation, a readout, of this underlying informational code. Your body, the chair you're sitting on, the air you're breathing, all of it could be complex informational patterns being processed by this cosmic computer. We are not just living in a simulation. We are the simulation. Our consciousness could be the emergent property of this incredibly complex information processing. Then there's the bizarre phenomenon of quantum entanglement, which Albert Einstein famously called spooky action at a distance. When two particles become entangled, they are linked in such a way that their fates are intertwined, no matter how far apart they are. If you measure the property of one particle, you instantly know the property of the other, even if it's on the opposite side of the galaxy. This seems to violate the rule that nothing can travel faster than the speed of light. How does one particle know what happened to the other instantly? In a simulation, this isn't so spooky. The two particles are just 2 points in the data. The distance between them in the simulated space is irrelevant. The code that links them simply says, if variable A is this, then variable B must be that. The change is instantaneous because it's a logical rule in the underlying program, not a physical signal traveling through space. Entanglement could be a telltale sign of the code that's running our reality. Finally, let's consider the speed limit of the universe, the speed of light. Nothing with mass can travel faster than light. Why should there be an ultimate speed limit at all? In a computer simulation, a speed limit makes perfect sense. It would correspond to the processor speed of the computer running the simulation. The speed of light would be the maximum speed at which the simulation can process and update the state of the objects within it. It's the refresh rate of our cosmic screen. This universal constant, which underpins so much of modern physics, could be one of the most obvious clues that we're reliving inside a system with finite computational resources. So, are we living in a simulation? The truth is, we don't know for sure. And maybe we can never know. If the simulation is perfect, how could we ever prove it? But the clues are fascinating. From the probabilistic argument and the pixelated nature of space-time to the strange rules of quantum mechanics and the universe's ultimate speed limit, the simulation hypothesis provides a surprisingly elegant framework that connects many of the deepest mysteries of physics. Perhaps the question isn't whether we're in a simulation, but what it means if we are. Does it make our lives any less real or meaningful? After all, your experiences, your thoughts, your emotions, they are real to you. And maybe that's all that really matters. Thank you so much for joining me on this journey down the rabbit hole. If you enjoyed this exploration of reality, make sure to hit that like button and subscribe for more mind-bending content. Let me know your thoughts in the comments below. Do you think we're living in a simulation? See you in the next video.